In this introductory video about fractions, we will see what is the numerator of a fraction and the denominator of a fraction. We will use the analogy of pizzas and pizza slices to represent fractions. We will see what are equivalent fractions. For example, 3/4 is equivalent to 9/12. And we will see what are improper fractions and mixed numbers. 5/4 is an improper fraction, and 1 1/4 is a mixed number because it contains both an integer and a fraction. We commonly see fractions represented this way: one number, a horizontal line, and another number below that. The number on top, represented by the A in this case, is the numerator. The number below the line on the bottom is called the denominator. Sometimes we will see fractions represented as one number next to another, separated by a diagonal line. If you see it this way, well, the first number is the numerator, the second number is the denominator. But for the rest of this video, I am going to be working with one number over the other. The numerator on top, the horizontal line, and the denominator on the bottom. Now, if we use the analogy of fractions represented by pizza and pizza slices, what we see is that the denominator, the number on the bottom, tells me how the original pizza was divided. For example, in 3/4, the pizza, this is how it came out of the oven, was divided into 4 equal slices. So here we see the pizza with 4 divisions. The number on the bottom tells me how the pizza was sliced originally. Now the number on top is telling me how many slices I have left. For example, in 1/2, the pizza was divided into 2 equal sides, and I only have one side remaining. In 2/3, 2/3, the pizza was divided into 3 equal slices, and I have 2 out of those 3 possible slices remaining. 3/4, well, the pizza was divided into 4 slices. I have 3 remaining, and you can divide it into as many slices as you want. For example, here the pizza was divided into 9 equal parts, and I only have 1 remaining. 1/9, 1/9. Here, the pizza was sliced like the hours on the watch, on the clock. We have 12 slices. So this figure could also represent the hours of the day. And this 1/12 right here could represent the time between 11 and 12. And here we have 1/30. I have never seen an actual pizza divided into 30 slices, but this could also represent the days of the month. For example, this 1/30, which is represented by the fraction here in white, could represent one day of the month. Now moving on to equivalent fractions. These are all equivalent fractions. Why? Well, let's take a look at the first two. In 1/2, that means that I have 1 slice remaining out of a possible 2 slices that the pizza was cut in half originally. On the next one, 6/12, the pizza was divided into 12 slices, and I have 6 remaining. So I have more slices on this side. I have 6 slices here. I only have 1 here. But all of these slices, all of the 6 out of 12 slices, are smaller. And when I add them up together, I have exactly half of the whole pizza. So it doesn't matter if I eat 1 huge slice or 6 smaller slices. In both cases, I am eating half of the whole pizza, how it came out of the oven. And the same thing happens if somebody cut the pizza into 4 equal sides and they gave me 2. They're giving me also half of the pizza. And if they divide it into 30 very small sizes and they give me 15, they are also giving me a total of half of the pizza. So 1/2 is equivalent to 2/4, is also equivalent to 6/12, and that is equivalent to 15 divided by 30, or 15 over 30. Now, how can we tell if fractions are equivalent? Well, one method that I have shown you is by drawing them and seeing, looking, inspecting that they are exactly the same amount of pizza. Different amount of slices, but same total amount of pizza. Now, if you want to do that just by numbers without having to draw anything, what you need to do is to find a common factor between the numerator and the denominator. That factor will divide both the numerator and the denominator, and the result in each case, in numerator and the denominator, has to be an integer. For example, what number divides both 9 and divides 12? I have to use the same number on the bottom and on the top, on the bottom and on the top, yeah, in the numerator and in the denominator. So here we can see that 9 can be divided by 3 and 12 can also be divided by 3. As long as I use the same number in the numerator and in the denominator, that does not change the value of the fraction. So 9 divided by 3 equals 3, and 12 divided by 3 equals 4. So we see here that we can change 9 divided by 12 into 3/4. That means that 9 over 12 is equivalent to 3 over 4. So here we are proving numerically that 3 big slices are just as much pizza as 9 smaller sizes, 9 out of a possible 12. Now what happens in this case? I have 7 out of a possible 4. If the maximum amount of slices that one pizza can hold in this case is 4, how can I write that I have 7 out of a possible 4 slices? Well, when the numerator is larger than the denominator, which is what's happening here, the number on top is larger than the number on the bottom, I cannot represent that with just using one pizza. I have to use at least one, at least more than one, at least 2. Let's see an example. When the numerator is larger than the denominator, that is called an improper fraction. So this is an improper fraction, 7 over 4. So what 7 over 4 equals is 1 complete pizza, 4 out of 4, and the 3 remaining slices have to come from another pizza. So I have 1 complete pizza and 3/4 of a second pizza. And this is how you represent that. 4 out of 4 plus 3 out of 4. 7 divided by 4, or 7/4, equals, again, 4 out of 4 plus 3/4. Now 4 out of 4 is 1 complete pizza. And 4 out of 4, or any number that you have, any fraction that you have the same number in the numerator and the denominator, equals 1, because it is 1 complete pizza in this case. So I can rewrite that as 1 plus 3/4, but I don't use the plus sign because I'm using a mixed number. This mixed number contains an integer, which represents the whole pizza, 1, and 3/4, which represent the slices coming from the other one. And this is how you change from an improper fraction to a mixed number. 7 divided by 4, 7/4, equals 1 and 3/4. Let's look at another example of improper fractions and mixed numbers. Now we have 7 over 3. How do I change that into a mixed number? 7 over 3 can be rewritten as 3 over 3 plus 3 over 3 plus 1/3. If you look at the numerators of all of this, they all add up to 7. And these two numerators are equal to the denominator. So this one equals 1, and this one also equals 1. Adding these two together, I have 2 plus 1/3. And this is what I have here, 2 and 1/3. So 7 over 3 equals 2 and 1/3. And if you want to see that, With figures, well, here it is. I have 2 complete pizzas and 1 slice out of a possible 3 of a third pizza. 7/3 equals 2 and 1/3. Thank you for watching all the way to the end. If you found this useful, please subscribe, tell a friend, and don't forget to check some of my other videos and the playlist. Once again, thank you, and see you on the next video.